So hello everyone, I'm Priyansh, ID number 24CA096, and I'm going to present various dependencies in an instruction life cycle. So first of all, let us go to our workspace. So here I have used Blender tool for the simulation of this project. So first of all, let us see what an instruction life cycle looks like. So it contains five phases, as we can see here. I have used five cubes for various phases, various stages of an instruction life cycle, through which every instruction, in order to be executed, must pass through all these phases. So if we look at the first one, then uh, it is IF, instruction fetch. Instruction is fetched in the first phase. In the second one, instruction is decoded. In the third phase, instruction is executed. In the fourth phase, it is memory access, means memory is accessed if it is a store instruction or a load instruction. And the final phase is write back, where the result of an instruction is written back in the registers. So these cubes, all these five cubes, indicate various life phases, various instruction phases for of an instruction life cycle. And uh, these I have used two spheres which indicate two instructions. This is the first instruction and this one is the second instruction. Now, if we talk about the instruction life cycle, then uh, there comes a concept of dependencies. First of all, let us see what dependencies means. It means that if any instruction is, as the name suggests, is and it is if an instruction is dependent on another, on the result of another instruction of its previous instruction, we can say, then that triggers to the concept of dependency. So when, for example, this is our first instruction to be executed in the order and this one is the second one. So if this instruction is dependent for its execution on the result of this instruction, then this is known as dependency. Now there are various types of dependencies. So now let us look at all these dependencies, what problems occur by these dependencies, and also the solution to these dependencies one by one. So the first dependency is RAW, read after write. Basically, if uh, the second instruction is dependent on the result of the first instruction, then it has to wait for the first instruction to be executed completely. So let us look at practically. So this is the first instruction, this is the second instruction. Now, as we look, the first instruction is executed and uh, the second instruction is decoded, but it does not get go in the next phase because it is dependent on the result of the second of the first instruction. So it has to wait until the first instruction writes back in the register. So this here we can see those instructions are indicated in red color. So a dependency has arrived. Okay, so the solution here is, there comes a concept of forwarding. What it means is, when the first instruction is executed, the result of it gets forwarded to the second instruction, so that it does not have to wait for the first instruction to fully write back into the registers the result of it. So as the first instruction gets executed, like we can see here, it passes through, the first one passes through the execution phase. So the result of it gets forwarded to the to the second instruction, and as we can see now, both of them have become green in color. and then both of and this dependency is resolved with the concept of forwarding. Now let us look at our second dependency. So it is WAW, write after write. This dependency arises when both of the instructions move parallelly in all the phases and both of them have to write back consecutively in the registers. So let us look at practically. As we can see, both of the instructions are moving parallelly, and as they reach this section, we can see that those spheres are in red color. If I can change the view, both of the spheres are in red color, indicating dependency has arrived. So the solution for this dependency is uh, the concept named stalling, or we can say reordering. So basically what it means is uh, the first instruction writes back first initially, and then only the second instruction gets executed and gets written back into the registers. So in this case, ordering is the key solution for solving this dependency. Okay, the second, as we can see, both the second instruction waits for the first instruction to write back, and as soon as the first instruction writes back, the second one also writes back. As we can see, green color. Wait, let me show you. Yes. So this means that both of them have written back. Both of them have become green. So this was the second dependency. Now let us look at the third dependency. So now let us look at our third dependency, WAR, write after read. Basically what happens here is uh, when the first instruction is reading from the registers in the final stage, that is the write back stage, and if at the same time the second instruction has to write something into the registers, then the dependency arises, which means that one instruction is reading, and at the same time the second instruction, another instruction, has to write back. So we can see that dependency arises. Let us see it practically. So if I start, this is the first instruction, this is the second one. They both pass through all these phases here. So the solution to this dependency is when the first instruction is reading from the registers, then it reads from register 1 R1, this one, and at the same time when the first instruction is reading, if the second instruction wants to write something, then it writes in this one, R1 dash. This concept is known as renaming, register renaming. Basically, the first instruction reads from this R1 register and the second instruction writes in this register, R1 dash register. So in this way, let us see it practically. This is the first instruction, it reads from R1 register, and this one is the second instruction that writes back in writes back in R1 dash register. And this is how this dependency is solved. As we can see, it has reached here. So yeah, this was all about various dependencies and how we can solve these dependencies during an instruction life cycle. Thank you.